Okay, today we're going to start chapter 11, and we're going to kick off by looking at 11.2, simplifying radical expressions. And we're going to start this by looking at what is known as the product property of radicals, which is this. So the square root of a times b, the square root of the product of a and b, is the same as the product of the square roots of a and b. Now this should be fairly familiar. This comes directly from the product property of exponents. So if you recall, if we've got a times b to the power n, that is the same as a to the power n, b to the power n. If we say that let n equal 1/2, a times b to the power 1/2 equals a to the power 1/2, b to the power 1/2. And then all we need to understand now that the square root of a is also known as the square root of a to the power 1/2. They are the same thing. So this leads us directly to this product property of radicals. And we can use this property to simplify radical expressions. So let's do a simple example. So the square root of 4x, we can split this into its two component pieces, the square root of 4 times the square root of x, and we can see that the square root of 4 has an integer value, which is obviously a simpler form. So the square root of 4x can be simplified to 2 times the square root of x. We can use these properties to simplify square roots of numbers which do not have nice integer coefficients, integer roots. So for example, let's say we have another example. Let's say we've got the square root of 32. Square root of 32. 32 is not a square number. It does not have an integer root. However, it does have a square factor. So 32 can be written as 16 times 2. And this can be simplified to the square root of 16 times the square root of 2, which can be written as 4 times root 2. And so some of you, when you look using your calculators and you do a problem on your calculator, you can try it now, type in square root of 32, and you'll see, many of you, that your calculator will give you this form, 4 times root 2, and this is the reason why. It's considered to be the simplest form. Let's look at one more example. Square root of 200. Again, we're trying to simplify this. Now, 200 has a number of square factors. Let's write down all the factors that we can think of, starting with the smallest, 1 times 200, 2 times 100, 4 times 50, 5 times 40, 8 times 25, and 10 times 20. Now, if we look at all of those, we can see that there are a number of these factors are square numbers. 25 is square, 4 is square, and 100 is square. And we can use any of these numbers to make a simpler version of the square root of 200. But if we want the simplest version, then we need to use the largest square factor. So in that case, that's this one here, the 2 times 100. So I shall write that with the square number first, 100 times 2, to the square root of 100 times the square root of 2, which is 10 root 2. And this is said to be the simplest form. Okay? So what I'd like you to do now is go to page 723 in your textbook, and there are a series of problems there. We'll just do questions 3 through 10. So they're here. Okay. There they are. And what I suggest you do is pause the recording now while you do these problems, check your solutions on the rear wall. You'll see that pinned up on the wall are all the solutions from these, for these problems on this page 723. And once you're comfortable and you think you know how to do this, then restart the recording and move on to the next section. Okay, right, we're going to continue with the next section here, and this time we're basically using exactly the same property, but we're going to do it in reverse. So in this case, we're going to express our property in this way. The square root of A times the square root of B is the square root of AB. So we can do it in very simple examples. Square root of x times the square root of x is the square root of x squared. And that can obviously be simplified to x. There are other problems we can do. Root 3x times 4 root x. Obviously we combine those values which are inside the radical and leave the ones outside on their own. It becomes 4 times root 3x squared. And clearly we can then simplify further. X squared can be simplified. So that becomes 4x root 3. Okay, now the problems 11 through 18 on the same page. Let me get some for you. And again, once you're happy that you understand this and you're getting these right, checking your solutions on the rear wall, then we'll move on to the next section. So pause the recording now and work through these problems. Okay, right. The next property we're going to look at is related in a very similar fashion. This time, instead of being the product property, it's the quotient property. So the square root of A over B is the same as the square root of A over the square root of B. Okay? Nice and simple problems. So let's look at some examples. Now, you're obviously going to be applying more than one property here. So the square root of 3x squared over 16, we can simplify. First of all, by separating the numerator and the denominator, finding the square root of each, and then simplifying each in turn. And so that becomes something like that. Problems here, 19 through 22. Okay. Okay, what we're going to talk about now is an odd little detail about radicals, stemming from some old design flaws in calculating devices, strangely enough. The expression which I've written up there, 1 divided by the square root of 2, this is considered to be somehow difficult to resolve. This comes from the fact that in the old days, calculating devices known as slide rules could not do this. You just physically could not divide by a square root. So mathematicians devised a way around this. So what we've got to try and do is turn the denominator of this problem into an integer. And we do that by multiplying it by itself. So the square root of 2 times the square root of 2. We need to multiply the top and bottom by the same thing, so we need to do exactly the same on the top. And this gives us this expression here. Okay? Now, this design flaw has spawned this particular technique, and it's held over in maths. We still use this, so you'll find that your calculators, when you try and do 1 divided by the square root of 2, you'll get this very funny looking answer, root 2 divided by 2. And this is the reason. It's just really a convention that we've got to follow, because all mathematicians do. Let's try another one. 5 divided by root 7, don't like that. So we're going to multiply top and bottom by root 7. 5 root 7 over 7. Okay? Now, sometimes further simplification is necessary. Let's try another one. 4 divided by root 6. Don't like that. Top and bottom by the square root of 6. And that gives us 4 root 6 over 6. And this can be further simplified to root 6 over 3. Okay? So this process is known as rationalizing the denominator. Okay? And there are examples of this on the same page, 723, section 26 through 33. Okay, so there are the problems. Work away. Once again, once you are completed and you're confident, check your work on the back wall and move on to the next section. Okay, right. We're now going to look at how we can combine radicals through addition and subtraction. It's fairly self-explanatory, really. Imagine we're adding a couple of radical expressions which have a common factor, and in this case the common factor is 7. Well, this is very straightforward. This is like adding anything with a common factor. We basically add the 4 and the 9, that gives us 13 root 7. It's just the same as if it was some kind of variable, so that would be 4x plus 9x is 13x. 4 root 7 plus 9 root 7 is 13 root 7, okay? Now, sometimes it's not obvious that they do have a common factor. They look quite different. But then you can look at the second component, the second expression, and realise that actually root 12 can be simplified a little bit further. So let's try that. So 8 times root 12 becomes 8 times the square root of 4 times 3. And that simplifies to 8 times 2 times the square root of 3, which is obviously 16 root 3. And they will then combine together. So 21 root 3. Okay? So there are some problems there a bit further down the page. It's questions 34 to 45 with those sorts of examples. Actually, having read it, let's not do 45, let's do it down to 39. Okay, do that section first, and we'll then extend this with the last of the new information for those last few problems. Okay. All right, so once again, once this is completed, pause and check your work and then move on to the next section. Okay, the last thing we're going to talk about is multiplication of radicals. So let's try this. Let's do an example. Okay, let's imagine we have a problem like that. Square root of 5 times this binomial expression, 5 minus root 3. Again, just using the distributed property, this becomes quite easy. We just have to follow the rules of multiplying radicals. So root 5 times 5 root 5, minus root 3 times root 5. So they go together. And that becomes 5 root 5 minus square root of 15. Let's try another one. Square root of 6 times root 3 minus 2 root 5 gives you a square root of 18 minus 2 times the square root of 30. Square root of 18 can be simplified, can be factored by a square number. That's 9 times 2. So that gives us 3 root 2 minus 2 root 30. And that is considered to be a simpler expression. So, finish off those problems, 40 through 45. Bottom of the page, let me give you those. Okay. Now, once you've done them, again, check on the rear wall, and I think finish off the rest of the day trying to possibly try the more complex problems on page 724. So work on to page 724. There are a series of problems there, 46 through 54. Which are a bit more complex and require a little bit more finesse. There's a few further down, 55 through 62, and then word problems from then on. Okay, so the word problems are on page 725, 67 onwards. The homework is 11.2c. There is a pile of homework. It's going to be distributed at the end of this lesson, and I will see you next time. Hopefully you will be on top of this and we can then move on to the next section. Okay.